All right, so this problem is asking us to determine which mechanism will happen, either substitution or elimination, and what's the major and minor product. So when we're talking about substitution, SN2 only gives us backside attack. So we get one, inversion of configuration, we get one product. With SN1, we get multiple products because you can attack from either side. For E1, you're going to favor the Zaitsev all the time, as long as there is a Zaitsev. And for E2, it depends on the size of the base. So the bulkier the base, the less likely we are to get the Zaitsev product. So recall in class when we were talking about, there was one of the problems that we did in class that when our base slash nucleophile starts becoming really bulky, it's not likely. So tert butoxide, for instance, it looks kind of like that. It's so bulky that it's not going to be a very good nucleophile. So it's a poor nucleophile. And it's going to have a preference for acting like a base instead. So it's going to be better at a base, but it's bulky. And because it's bulky, it's going to have a preference for getting hydrogens from the easiest side. So I'm only going to draw in two sets of hydrogens. This I'm going to call hydrogen A and hydrogen B. If we were to do an elimination on side A, and I'm going to draw that it's the same mechanism for side B. Because this is secondary, it's going to favor E2. You may get a little bit of E1, but it's going to favor E2 because this is a strong base and it's secondary. So secondary plus strong base is going to favor E2. Now, my major product is going to be the Hofmann product, which is going to look like this. My minor product is a Zaitsev just because the base is large. Okay, so that's going to be our minor product. We can either be the Z, which is, E, which is the next most minor, which is still going to be a little bit more than the Z product. The Z is going to be even less. Okay, so those are all my possible products. Now let's look at B. B is saying that you have sodium hydroxide and you have a primary group. So hydroxide is both a nucleophile and a base. Since it's primary, it could only be SN2 or E2. And so I would likely get both things happening. Since hydroxide is a strong base, you should get some E2. Because it's primaries that are not very bulky don't really want to form the monosubstituted alkene. And so our major product is actually going to come from the substitution. And so this would be our major product. We're just going to substitute the Cl for the OH. And our minor product is going to be the E2, which would look like that. So remember that monosubstitution is very hard to form. So this is not going to be easily formed. Now, if I were to increase the temperature, then I start favoring E2. But because they didn't say that, you can't imply that, okay? So for part C says that we're using ethoxide with a secondary. So we're going to have something very similar. We're going to be getting elimination and substitution since it's secondary and you have a strong base slash nucleophile. You will favor E2 and SN2. Since it's a strong base, you're going to get our major product is actually going to be the Zaitsev, unless we make this reaction really, really, really cold, because disubstitute is pretty stable. And the ethoxide, though it's somewhat small, it's not extremely small. So you will still get some of the Hoffman products. So we'll get this, then this. Plus we'll get some SN2, but it's going to also be minor. Okay. So let's look at the next ones. I'm just going to move this down. So for the next one, we'll look at this. We're going to use this structure with ethoxide in our ethanol. Oh, actually, I skipped one. So D. We're using D. And since we're using a strong base with tertiary, so remember, E2 can happen with all of them, but because we're using a strong base, we're going to have a huge preference for E2, a very slight preference, a very tiny amount of SN1 happening. So our major products are going to be the elimination to give us the Zaitsev product, because our structure is not terribly large. Our base is not very large. We're going to get some of the minor product. Oops. And a very, very tiny amount of substitution. Very, very minor. All right. And for, sorry, that's D. For E, let's go back to E. E is using this structure, so we're going to redraw that structure. And we have ethoxide, again, as our base and our nucleophile. Since it's a strong base, it's likely to undergo our elimination. So since it's a strong base and a strong nucleophile, and this is secondary benzylic, we're going to have a preference for SN2 and E2. But because this is a strong base, we're going to have a little bit of a preference for E2. And so our E2 products would look like this. So this would be our major product. And again, if I made this even colder, then we'd get more of the SN2. And so our minor products are going to look like this. So we always get the one that is, the Z is always going to be a minor product, and the E is always going to be a major product, no matter what, as long as the structure can be rotated around. And then some SN2. So a minor amount of SN2, a minor amount of the Z, and a major amount of the E. We also could, like I said, if we drop the temperature, which the question doesn't indicate, if I made the temperature colder and colder, we're going to start having a preference for this one. Or if the structure couldn't be rotated, then we might see differences in E and Z. So F is a similar structure, except it has this thing on it. And important thing to remember is, since E2 is the only thing we could potentially have on our structure, or SN2 under these conditions, remember we need to have our hydrogen, and if I draw in the hydrogen, we need to have it antiperiplanar, and currently, or anticoplanar, currently it's not, so we would need to rotate around that bond. And if we do that, The only way for this, and remember I said some reactions you can force E versus Z. This is one that if I rotate this around and push this like that, I can get the hydrogen to be kind of opposite to, oops, let me just rotate a little bit. I can get the hydrogen down here like this and like that. And so if I were to rotate this a little bit, I can get the hydrogen in a position that I can get some reaction. So if I rotate it a little bit more, I can get something that looks like this. And so just try rotating it with like a model kit so you can understand what I'm talking about. But basically, you just keep rotating until the structure is going to give us the anticoplanar. So right now it's anticoplanar. That's the only way E2 can happen. In the previous example, the hydrogens are automatically, since it's only hydrogens here, they're going to be, one of them is going to be in the right orientation. So in order to do this, remember, think about the transition state. And I'm just going to draw not the transition state, but just an example. This thing has to leave, double bond has to form, the hydrogen has to go. Okay, and I will draw in actually the transition state. So your base will have to come in and cause that to leave. And by doing that, that means this group over here, and I should have put a, this is not a wedge. Let me make that a little bit more clear. So the bromine, this is straight. This is actually a wedge right here coming to that. So this is a wedge like that. So that would mean that this ethyl group and this phenyl are going to be on the same side. So when I do this elimination, I end up with something that looks like this. Okay, so in this case, I end up with Z just because there's no other possibility. Our minor product of this reaction will also be, we only get the Z in this case, only Z for the elimination. And we still get the same substitution product. That's not going to change. Okay. All right. There's two more. So G, we have a strong base and this structure. So since this base is bulky, it's tert-butoxide. It's a strong base, so I'm gonna favor E2 versus, even though it's tertiary, it's still, remember, E2 can happen with primary, secondary, or tertiary. Primary, not as reactive though. I can remove the hydrogen, and because it's so bulky, it's gonna prefer the side that's the least bulky to remove one of those hydrogens. I only drew in one, just as a reminder. There are other hydrogens on there. And so my major product is going to be my Hofmann product as the major. My minor product is going to be the Z alkene in the more in the Zaitsev. And then we have the E alkene. Sorry, this is the E, and then this is the Z. Okay. Now there will be a very, 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 very tiny amount of SN1. Very tiny amount, nothing to really write a home about. It's so minor that we don't really care about it. It's like almost none. And then H, we have the same kind of structure, except we don't have a big base. So again, we'll still get a little bit of this, plus it's an enantiomer. But a again, it's a very tiny, almost insignificant. We'll get the same thing down here, but again, very insignificant. But here, because I'm using methoxide, it's so small that our major product is actually the opposite. So our major product, it's the E Zaitsev. Then a little of the Z Zaitsev product, and then another minor product, which would be this.